time. Yes, here we go again. Yeah, on to lesson 10. We are kind of cruising through this world of decimals. Now, today's lesson, we're going to go pretty quickly through because this is setting up for future lessons, especially the review part at the beginning. We'll kind of cruise through, and then when we get to the comparisons later on, we will have to slow down a little bit. Okay, so let's see what we're doing today. Our objective, we're going to use area models. Okay, right, drawing out the charts and the number line, we remember him, to compare decimal numbers. So we're going to use less than, greater than, equal to compare numbers in decimal form. We can do this. Let's do it. All right, so here's our quick review to get us back in that math head. This is what in unit form? It is 1, 1. Great. Now how many tenths is that? Bring it over and it's 10 tenths. Told you we're going to go kind of quickly through this. So if any of this confuses you, go back to lessons 8 and 9 there. How about this? 1, 1, 2 tenths. What would that be all in tenths? Bring this over. You now have a total of 12 tenths there. How about now? We have 1 tenth. Very good. How many hundredths is that? And be careful, there's a tendency to say 100, because we were just saying 10 tenths to say 100 hundredths. But think about it, a dime is how many pennies? It is indeed 10 hundredths, 10 cents, 10 pennies. What's this number in unit form? 1 tenth, 2 hundredths. Great. What would that be all in hundredths? Bring this tenth over as 10 hundredths. You have a total of 12 hundredths. Now what do we have in unit form? 2 ones, 3 tenths. Okay, how many tenths would that be altogether? Bringing these 2 ones over would bring over a total of 20 tenths. With the 3 there, right, 23 tenths. Now, look at that. It's the same number, 23 tenths, isn't it? But how would we read this as a math number? Not 2.3, that's how we'd say we write it as a math number. It is 2 and 3 tenths. Great. How would we write that as a mixed number? 2 and 3 tenths, and we already have it written as a decimal, 2 and 3 tenths. How about this? 4 and 6 hundredths. As a mixed number, 4 and 6 hundredths, decimal, 4 and 6 hundredths. Great. This all looking familiar? That is why we're kind of cruising through here. What's this number? 1 and, read it together, 23, where are we? Hundredths. 1 and 23 hundredths, 1 and 23 hundredths. This number, 40 and 7 tenths. Do it with me now. What do we have here in mixed number form? 40 and 7 tenths. Decimal form, 40 and 7 tenths. We could also call this 40 and 70 hundredths. Very good. All right, now how about this? 68 and 5 hundredths. 68 in the mixed number and 5 hundredths. 68 and 5 in the hundredths place. Beautiful. All coming back to you. Now here's a decimal. We're going to go write it as a mixed number and then all in tenths and all in hundredths. And again, this is all kind of a quick review. So cruising through here. 3 and 1 tenth. 3 and 1 tenth as a mixed number. As the improper fraction, we know this 3 is 30 tenths with the 1 already here. So total of 31 tenths. Now in hundredths, we're just times 10 tenths, right? Like with equivalent fractions. 310, 310 hundredths. Excellent. Here's another one. 9 and 8 tenths. What would that be as a mixed number? Exactly what I just said. 9 and 8 tenths. Improper fraction, 98 tenths. In hundredths, times 10 tenths for the equivalent fraction, 980 it would then be 980 hundredths. Beauteous. Let's do it with this one. How about that? 64 and 3/10, mixed number, looks just the same. 64 and 3/10. Now, this is where you might check yourself and say, how many tenths would that be? Well, this is 640 tenths, isn't it? Plus the 3 here, so 643 tenths. And then you might check yourself again when you get to hundredths, because it just looks odd, but it's correct. That times 10 tenths, that would give us 6430 in the numerator, 6,430 hundredths. Woo-wee, zooey mama, how about that? Now we're on to the little question here. We have some girls. We got some beakers, girls with beakers. In science class, Emily's 1 liter beaker. Okay, so 1 liter is the full capacity, like when it's empty. That's how much you can fill it up to. The top line says 1 liter. But how much water is in it? 3/10 liter of water in there. Allie, on the other hand, Allie's beaker contains 8/10 liter of water, and Katie's beaker contains 63/100 liter of water. Okay, so they're all in decimal form. That's nice, but we notice these two are in tenths, and this one is in hundredths, so we have to take that into account. Question though is, who can pour all of her water into Emily's beaker without going over 1 liter and making a mess all over the science room floor? Is it Allie or Katie? Well, let's find out. This is where tape diagrams are really useful. So we teachers don't have you draw these because we like to see you suffer, although sometimes we do. No, just kidding. But because it helps you to see what you're doing. So we have Emily, Allie, and Katie. So Emily's is 3/10 liter. Well, how many hundredths is that? It would be 30 hundredths, right? So we're going to write 3/10 liter because that's what we're given here. And now when we look at Allie, 8/10. Well, how many hundredths is that? 80 hundredths, right? So that one's going to be more than twice as long, right? Because this double would be 6/10. So 8/10 is going to be a little bit longer than double the length of Emily's there, okay? So there's our 8/10 liter, aka 80 hundredths. And now here's Katie. Hers is 63 hundredths. Now this is where you have to stop and think for a minute. Okay, so it's 63 hundredths. We know this is 30 hundredths, this is 80 hundredths. So 63 is going to be between, its length will be between the length of Emily's and Allie's there. So about, 63 hundredths liter. All right, now the question, however, is who can pour theirs into Emily's? Well, see, let's start by saying how much room is there in Emily's? What does it take to go from 3/10 of a liter to 1 whole liter? Well, 3/10 plus what is 1? 7/10, okay? So 7/10 is what we need. Do you remember this, the arrow way that we did way back in fraction land? Yeah. So we can fit 7/10 in there. All right, well, look at Allie's, and we're comparing decimals here is what we're doing. We can compare 8/10 to the 7/10 of space, and I think we could see fairly straightforwardly there that 8/10 is more than 7/10. So Allie, shink, shink, not you. Katie, however, she has 63 hundredths. All right, well, we know this 7/10. We could imagine the 0 there and call it 70 hundredths. So yes, 63 hundredths is less than 70 hundredths, also known as 7/10. So it indeed is the fine young lady, Katie, who can fit it. And this would be, if you're taking a test kind of thing, or just speaking out loud and explaining yourself, this would be a good explanation. So good, I'm going to read it. Emily's beaker can only fit 7/10 liter water more. 8/10 liter is greater than 7/10 liter, so it would spill. So, to Allie. Katie's water will fit because 63 hundredths is less than 7/10. If you understand that, then everything else we do is going to be a bit easier. If this has you a little confudulated, you need to hop back to lessons 8 and 9 there. We're going to go on though. All right. What we do, comparing pairs of decimals using an area model. And we're going to kind of move a little quickly through the start of this with the area models and the number lines to get to the juicy part. Here we go. Ooh, what have we here? 15 hundredths. Okay, great. Oh, ooh, who's that? Oh, it's 51 hundredths. Same digits, mirror world, confusing. No, we know that 15 cents is less than 51 cents. So we go and compare. 15 hundredths is exactly less than 51 hundredths. And that's the easiest example you're going to get today. I hope you enjoyed it. Here we go. So there they are with the area models. We would draw these out and say that's what 15 hundredths look like. That's what 51 hundredths looks like. All right, now we know. All right, 30, see, I told you that was the easiest one. Let's look back. Oh, that was such an easy one. Those days are over. Here we go. 37 hundredths compared to 3 tenths. Now there will be a tendency here to write off, and you might be right, you might be wrong, but to say, 3 is less than 37, so 37 is greater than 3. Now, you might be right, you might be wrong, but that is the wrong logic. Yes, we are not doing coin flip here. 3 tenths is equal to how many hundredths? Yes, 30 hundredths. So now 37 hundredths is, yes, more than 30 hundredths, okay? And in each case here, I won't be writing it out. I want you to start being able to visualize it in your mind. Dig it. All right, so that's greater then. All right, here's another one. 27 hundredths compared to 7 tenths. Again, tendency here to be able to say, 27 is more than 7. Next, ding. But in this case, you would be mistaken. 27 hundredths, this is 7 tenths. How many hundredths? 70 hundredths. So 27 cents is, yes, less than 70 cents, isn't it? You see that? Great. Here we go. What are they doing to us now? 7 tenths, 70 hundredths. We can imagine the zero there. Yes, 70 hundredths. 70. Look at that, an equals. They hardly ever give us an equals. I'm so happy to see you, equals. Your beautiful parallel lines. All right. 6 hundredths compared to 6 tenths. Okay. Let's put this into hundredths. That zero there, right? It would be 60 hundredths. 6 cents is much less than 60 cents, right? Okay, so 6 hundredths is less than 6 tenths. Excellent. Now, we're going to do the same thing using a number line. And then we get to the juicy part. Here we go. 4 and 5 tenths compared to 4 and 38 hundredths. Okay? And you might say, 5 is less than 38. This number is longer than that one. You might be right or wrong, but the logic is flawed. Let's use Mr. Happy Little Number Line. Hello, Mr. Happy Little Number Line. How are you? Okay, never mind. All right, so here is 4 and 5 tenths. 4 and 38 hundredths would fall before, well, let's call this 4 and 30 hundredths and 4 and 40 hundredths. So 4 and 38 hundredths would fall between them, right? And there's 4 and 5 tenths, which we could also call 4 and, that's right, 50 hundredths. So which one is greater? So this would be 4 and 5 tenths is greater than 4 and 38 hundredths. Woo! How about them beans? All right. 6 and 37 hundredths compared to 6 and 3 tenths. I bet you're starting to get the hang of this, right? We see 6 and 3 tenths is there. Where would 6 and 37 hundredths be? Well, if we imagine all these numbers here in hundredths, just by tacking on that zero here, this would be 6 and 30 hundredths. This would be 6 and 40 hundredths. So 6 and 37 hundredths would fall between them, about yay. But it's definitely greater than 6 and 3 tenths. All right, we see why on the number line? Yes? And again, I'm having you picture it in your mind here instead of drawing everything out for you. 2 and 68 hundredths compared to 2 and 8 tenths. Well, 2 and 8 tenths is right here on the number line, but to place the 2 and 68 hundredths, we have to, in our minds, visualize those zeros that turn everything into hundredths here. So where would 2 and 68 hundredths fall here? Between 2 and 60 hundredths and 2 and 70 hundredths. About yay, right? Well, we see 2 and 8 tenths is up there. So in our statement here, 2 and 68 hundredths would be, there it is, it's less than 2 and 8 tenths. Got it? All right. Now this one, yeah, do one of those. 10 and 1/10, very good. 10 and 10 hundredths, 100, right? Here is 10 and 1/10, great, that's right there on the number line. When we look for 10 and 10 hundredths, you're getting the hang of this, right? You imagine these all with the zeros on the end? And so 10 and 1/10 is equal to 10 and 10 hundredths, isn't it? $10 and 1 dime is the same as $10 and 10 pennies. They are the same. Oh, there's our good little friend Mr. Equals again. Hi. Okay. 10 and 2/10 compared to 10 and 2 hundredths. And again, we could use the number line, and we will, but you can also use money here. Okay, so here's 10 and 2/10. It's right there. Where would 10 and 2 hundredths be? Oh, yes, way back, because this would be 10 and 00 hundredths, so to speak. 10 and 10 hundredths. So 10 and 2 hundredths would be way back here, close to 10. And here's 10 and 2/10. And again, related to money, this would be $10.20, $10.02. $10.20 is obviously greater than. Very good. All right, we got one more set here. You ready? Breathe. All right, let's do it. Here we go. 6 and 24 hundredths compared to 5 and 24 hundredths. Well, it doesn't even matter, honey, what comes after that decimal point now, does it? I mean, they happen to be the same digits, but it doesn't matter because 6 and anything is more than 5 and anything. So this is one of those kind of ones where you don't want to overthink it. It's just like, oh, 6 and something, 5 and something, 6 is more. Done. All right. Now, there you go. There you go. Look at it adoringly again. That's the easiest one you're going to get in this set. All right, moving on. 13 and 24 hundredths compared to 13 and 42 hundredths. And again, they're trying to rattle our brains by using the same digits. Yeah, think to money, yeah. 13 and 24 cents, $13.42. The 24 cents is less than. Very good. 48 hundredths, 2 and 1/10. Well, I suppose this one then is another kind of gimme. This is less than 1, right? There's a 0 in the ones place. This is more than 2. And that's all you really need to know. Like we could say this is 2 and 10 hundredths, but we really don't need to. We know this is 2 and anything is more than a number that's less than 1. So 48 hundredths is less than 2 and 1/10. How about these apples? 2 and 17 hundredths compared to 2 and 7/10. I think we should put this one into hundredths, right? We'll put that 0 there in our mind saying, okay, this is 2 and 70 hundredths. 2 and 17 hundredths, 2 and 70 hundredths. Again, related to money. 2 and 17 cents, $2.70. 17 cents is less than 70 cents. Beauteous. 3 and 3/10 compared to 3 and 30 hundredths. I bet you got that one. I bet you already gave me an answer before I even read the whole thing. Well, obviously, yes. We put the 0 here to convert that to hundredths, and we can see quite easy. There it is. Our beautiful love equals. All right. 7 and 9/10 compared to 7 and 9 hundredths. Oh, we had one just like this before. Different digits, but same idea. We can place that 0 here and make this 90 hundredths compared to 9 hundredths. 90 hundredths would be more than 900. So greater than on that one. 8, getting tired? Blink, 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 blah, blah, blah. Moving on. 8 and 2 hundredths compared to 8 and 2 tenths. This is similar to the last one, isn't it? Yeah, it is, but this time you just have a fraction. But when you read it out loud, you can see that this would be written as 8.2, 0, $8.02, $8.02, $8.20. 2 cents is clearly less than 20 cents. Very good. 5 and 3 tenths, 5 ones and 3 hundredths. This is actually the same as the last two, isn't it? Just with different digits. This would be 30 hundredths. This is 3 hundredths. Which is more? 30 hundredths clearly is more than 3 hundredths. And they both have the 5, so we could just look at the less than 1 fractional part there. 5 and 2 tenths, 52 tenths. All right. How many tenths is this? And this is what we did in that warm-up not so long ago. 52, what place am I in? Tenths. Oh, look at that. 52 tenths, 52 tenths. 5 and 2 tenths. The value of this is 5 and 2 tenths. Indeed it is. So these again, oh, you've come back to me, beautiful equals. Oh. 4 ones and 6 tenths. 4 ones and 60 hundredths. Let's try relating this to money. $4 and 6 dimes. $4.60. 6 dimes, 60 pennies. 6 dimes, 60 pennies. 6 dimes, 60 pennies. Stop, stop, stop. They are equal again. Ah, lovely. 25 hundredths, 25 tenths. Ah, that's right. Hundredths are cents, aren't they? And tenths are dimes. So 25 cents, right? Isn't that how you'd write 25 cents in money? And this is 25 dimes. You see that, huh? How much money would this be, 25 dimes? Yes, well, we can do this a couple of different ways. We can multiply by 10 tenths. Oh, I didn't mean to hit that. We can multiply by 10 tenths, say there's 250 hundredths. So 25 cents compared to 250 cents, which is $2.50. So obviously 25 cents is less than $2.50. All right. The end is near. Fear not, dear one. 237 hundredths. 270. Sorry, I jumped the gun. That's what I was going to do next. 2 and 73 hundredths, which we can read as, yes, I blew it, 273 hundredths compared to 237 hundredths. When you look at it that way, you can see that this is less. 237 hundredths is less than 273 hundredths. And now you see why we learned how to read them that way in a couple lessons ago. Oh boy, 4 tenths, 45 hundredths. Again, I find relating it to money is very useful here. 4 dimes, 45 pennies. Well, 4 dimes is 40 cents. 45 pennies is 45 cents. 40 cents compared to 45 cents. 40 cents is less. Excellent. 2 and 31 hundredths. And now they're messing with us. 23 tenths and 5 hundredths. Okay, well, 23 tenths. How do we write that? Let's just look at that for a moment. As a decimal. It would indeed, we'd write it as 2.3. We'd write 23 such that it ended in the tenths place. So 2.3, and then with the 5 in the hundredths place, it would be 2.35. Ah, now we can do this. 2.31, 2.35. 2 and 31 hundredths, 2 and 35 hundredths. This clearly is less. See, so if you think these through, you can always figure these out. They just take a little bit of crunching the gears there. And look at it. You've done it. you've gotten your way to the problem set. Doing here, same thing we just did. Shade in the old area model there and do greater than less than equal to. A little bit more of that. And then the same thing with the number line. Mark the 2 dots. So there's no hopping on the number line here. You're just marking 2 points on the number line. So you can compare greater than less than. And then doing it the raw juicy way here. Greater than less than equal to. Zumba. And they start off easier. And then they get into that confudulating stuff. But you can do that because we just did it together. Exit ticket. Same thing, but less of it. And of course, when you get to happy homework land, you know what to do. Head on over to Homework Time videos and we'll do the homework together. Well, look at what you've done. I know that one was a lot of work. Whew. Well, congratulations to you because you did it. Here you are at the end. And here's your prize. You learned lesson 10. So I will see you again next time. It is once again lesson time.